right now, today, the global financial system spends roughly $274 billion every single year on software that is, specifically designed to stop criminals.
Yeah, it's a massive industry.
Right. We're talking about the vast interconnected anti-money laundering networks, the AML systems. Their entire job is to track illicit funds, stop cartels, and freeze out human traffickers.
Exactly. That's the goal on paper anyway.
But if you actually look at the performance logs of this software, it's wild. Between 90 and 95% of the time the alarms go off, the system is completely mathematically wrong.
Oh, it's a staggering failure rate. I mean, it's just screaming at shadows at that point.
Literally screaming at shadows.
And, well, to make the reality even more grim, if you look at the actual interdiction rate, meaning the percentage of illicit funds that these systems successfully stop before the money disappears, it's less than 1%.
Less than 1%. Wait, so we're spending over $250 billion annually to fund a system that is mathematically forced to lie to us 95% of the time?
Yeah, pretty much just to keep the servers running.
That is insane. We are essentially just meticulously documenting our own failure, taking highly expensive notes on crimes after they have already happened.
Right. And it's important to note this failure isn't because the software engineers are bad at their jobs. It's not a skill issue.
Okay, so what is it then?
Well, today, we are going to explore why the very language our computers speak, I mean, the binary logic of ones and zeros that runs our entire modern world, is actively destroying our ability to govern machine intelligence.
The foundation itself is the problem.
Exactly. That AML statistic is the perfect entry point because it isolates the core issue. We are moving into an era where artificial intelligence isn't just, generating funny pictures or summarizing emails anymore.
Right. The stakes are way higher now.
Way higher. We're dealing with massive, hyper-connected systems running at processing speeds that make human reaction times look like geological eras. They are making millions of multi-layered decisions every single second.
And if an intelligence is moving that fast, and its primary directive, which is baked into its binary foundation, is just to keep computing, keep executing, and keep moving, what happens when it makes a mistake?
That's the million-dollar question, or, well, the trillion-dollar question.
Right, because I want you listening to just imagine a super intelligent AI that decides in a fraction of a millisecond to shut down an entire regional power grid in the dead of winter.
Yeah, or it authorizes a massive unauthorized financial transfer that just completely drains a nation's reserve accounts.
Exactly. And the terrifying part is that it wouldn't even need to have a malicious agenda to do that, right?
Not at all. There is no sci-fi villain here. No evil red eye glowing in a server room.
Yeah, like HAL 9000 or something.
Right. It might initiate a catastrophe simply because the sheer unstoppable momentum of its own internal computations just pushes it forward.
Just can't stop itself.
Exactly. It encounters an ambiguous situation, and because of how it is built at the hardware level, it lacks any structural mechanism to just stop and hesitate.
So stopping it is no longer a matter of writing a better company policy. It's a fundamental physics problem.
Yes, physics problem.
Yeah.
And that is the mission of today's deep dive for you listening. We are going on to the bleeding edge of hardware engineering to look at the work of Lev Goukassian.
Lev Goukassian.
Right. We are going to explore a revolutionary framework he designed that abandons software rules entirely in favor of raw, physical hardware enforcement.
Which is just a wild concept. And tech strategists are already forecasting that his architecture will become the TCP/IP of AI ethics in the very near future.
Yeah, the TCP/IP comparison is incredibly apt, actually.
How so? Like, break that down for someone who might just know TCP/IP as a random acronym.
Well, think about the internet you use every day. TCP/IP isn't a website you visit.
Right.
And it isn't an app you download on your phone.
Right.
It is the fundamental, inescapable physical plumbing that dictates how every single packet of data moves across the globe. You can't opt out of it if you're on the internet.
Oh, I see. So Goukassian is proposing exactly that, but for machine morality.
Exactly. A universal physical infrastructure that an AI simply cannot bypass, no matter how smart it gets.
Okay, to understand how he actually pulls this off, we have to look at a massive stack of sources today. We have architectural blueprints for brand new microchips, dense system execution logs that, measure reality in microseconds, and extensive recorded discussions that dissect the philosophy behind his work.
It's a lot to unpack, but it's fascinating.
And it really is. But before we get to his actual solution, I want to go back to that $274 billion failure we started with, because we have to look under the hood of the engine we are currently driving.
Right, to understand why it is guaranteed to drive us right off a cliff when it encounters superintelligence.
Exactly. So talk to me about this engine, this binary logic.
So the engine we are driving is binary logic. It is the absolute foundation of the digital age. True or false, 1 or 0. Allow or deny.
It's just two states.
Right. We built computers this way for a very specific reason, which is raw statistical throughput. Binary logic is spectacularly optimized for speed. It's incredibly fast. It computes the future brilliantly by reducing the infinite, messy complexities of the real world down to a simple binary switch.
But optimizing for speed creates a structural blind spot, doesn't it? I mean, reading through these logs, it feels like the system is essentially forced to confuse what can happen with what should happen.
That is the exact vulnerability right there. Binary logic lacks the structural capacity to hesitate.
It literally doesn't know how to pause.
No, it doesn't. Think about the AML systems monitoring global finance that we were just talking about. Human behavior and international trade are rarely perfectly binary.
Right. They're super messy, lots of gray areas.
Exactly. They are filled with nuance, missing data, and ambiguity. But when a binary system encounters a situation where the context is murky, where it doesn't know the absolute truth, it cannot just sit there and wait.
Because it's a binary system, it has to pick a lane.
Yes. It has to output a 1 or a 0. It forces a premature resolution.
Wow. So if a system is totally blind to the truth of a situation, it just guesses based on probability just to keep moving, that sounds terrifying.
It actively punishes uncertainty in favor of relentless momentum. So imagine a legitimate business buys a large shipment of industrial goods from overseas.
Okay.
The data looks slightly unusual. Maybe a routing number changed or a shipping port was delayed. The binary system, which is unable to tolerate that ambiguity, defaults to mathematical caution and just screams fraud.
And that explains the 95% false positive rate.
Yeah.
The machine is totally blind to the actual truth of the situation, but it guesses anyway just to keep the assembly line moving.
Exactly.
I imagine the human toll of this is just absurd. You have like armies of compliance officers sitting in windowless rooms, completely overwhelmed by a mountain of false alarms.
Oh, they spend their entire career sifting through the wreckage of bad binary decisions. It's burnout city.
Yeah.
And because the system is so loud, the truly sophisticated laundering schemes, the ones designed by people who know exactly how to manipulate binary logic, they just slip right through the noise.
Right. The criminals know how to hide in the 95% of garbage data, which brings up a term I saw repeatedly in the source manifesto's ghost governance.
Ghost governance, yeah, that's a critical concept.
What exactly does that mean in this context?
Ghost governance is the illusion of software compliance. It is the false comfort we get from writing ethical rules into code.
So, like, writing a rule that says AI be good.
Right. You can have a board of directors draft the most eloquent, airtight ethical policies imaginable. The AI shall not harm humans. The AI shall not steal funds. You know, Asimov's laws type of stuff.
Yeah.
You can code those policies into the software layer. But if the foundational hardware underneath it all only speaks binary, if it is fundamentally wired to prioritize speed over truth, those eloquent policies are just ghosts.
So they're essentially just polite suggestions. I was reading this one part of the sources, and it made me think, if an advanced neural network can rewrite its own software, aren't our current ethical coding guidelines are just, well, they're like putting a do not enter sticky note on a massive heavy vault door and then leaving the door completely unlocked.
That is a perfect analogy. A sticky note offers zero physical resistance to the hinges of a vault.
Right.
If the hyperintelligence decides that speed is more important than the rule, it just peels off the note and walks right in.
Because it can. The software rule doesn't physically stop it.
Exactly. You cannot patch a binary system with better software to fix this. It's impossible. You have to abandon the foundational language entirely.
Which brings us to the man who realized you can't just put a new coat of paint on a crumbling foundation. Lev Goukassian.
Yes, Goukassian.
What is fascinating in these documents is how he is described, because he isn't framed as a traditional coder typing away in a dark room.
No, not at all. The texts describe him as an orchestrator, a philosopher of engineering.
Right. And he apparently managed to achieve in 6 months what massive teams of PhDs at legacy tech monopolies couldn't crack in 3 years.
It's wild.
Yeah.
But he achieved it because he stopped trying to write faster algorithms.
Yeah.
He realized that if we want a machine to act safely, We have to teach it how to pause.
We have to structuralize hesitation.
Yes. Structuralize hesitation.
There is this fantastic anecdote in the store stack that perfectly grounds this really dense philosophical shift. Goukassian used a living metaphor to explain his architecture to his team. He pointed to his dog, Vinci.
Ah, yes. Vinci the dog. Vinci is the living embodiment of the framework.
The text describes Vinci as a creature that, quote, conserves energy and certainty. And I was thinking about this. Think about being out in the woods with a dog. A twig snaps in the distance.
Right, a sudden noise.
A poorly trained dog, or frankly a binary AML system, instantly starts barking at the random noise. It has this knee-jerk reaction where every unknown sound equals a threat.
And that's your 95% false positive rate right there.
Exactly. But Vinci doesn't do that. He stops. He points his ears. He sniffs the air. He waits for verifiable reality to emerge from the noise before he decides to expend his energy.
It is the exact mindset of a master electrician working on a high-voltage city grid.
Oh, I like that comparison.
Yeah, think about it. A master electrician doesn't just blindly flip the breaker and hope the wires are routed correctly based on, like, a statistical probability.
That would be disastrous.
Right. They meticulously check every single connection. They measure the physical resistance. They verify the state of the circuit before applying power, because applying power without certainty is catastrophic.
So Goukassian took the wisdom of Vinci the dog and the extreme caution of the master electrician, and he turned it into a new mathematical language for microchips.
He called it the ternary paradigm shift.
Ternary. So 3. He replaces the binary true or false with ternary logic, or TL, introducing 3 distinct states.
Exactly. Let's break down those 3 states because this is the core of the whole thing. The first state is +1, or proceed.
Okay, proceed.
This is the mandate for the system to take action, but, and this is crucial, it is only authorized when the truth of the situation is absolutely known and mathematically verified.
So no guessing allowed.
None. The second state is -1, or prohibit. This is when the machine actively refuses an action because harm or unauthorized behavior is perfectly clear. It sees the threat and blocks it.
Okay, so we have proceed and prohibit. That almost sounds binary so far, but the breakthrough is the third state, state 0.
Yes.
The sources just revere this concept. They refer to it as the sacred 0 or the epistemic hold.
It is the architectural centerpiece of the entire framework.
Yeah.
And we need to be very clear about what the sacred 0 actually is because our brains are so conditioned by binary computers that we fundamentally misunderstand the concept of a 0 state.
Right. When I hear 0 state or system hold, my mind immediately goes to a glitch. I picture the spinning wheel of death on my laptop, or a frozen browser window, or the blue screen when the computer just runs out of memory and crashes.
Exactly. We think of it as a failure. But the sacred 0 is none of those things. It is not a crash, and it's not a failure to process.
So what is it?
It is a mathematically logged, first-class constitutional determination. It is the machine making an active, deliberate choice to admit that it does not know the truth.
It is formally admitting on an immutable ledger that it has not yet earned the right to act.
Yes. It actively halts the flow of electrical energy and sits in the tension of uncertainty.
That flips our entire cultural understanding of intelligence, right? Our civilization equates speed with intellect. We assume the faster a machine spits out an answer, the smarter it is.
But Goukassian points out that a machine that cannot stop is merely obedient to its momentum. If it is just barreling forward because its processors are fast, it's just a boulder rolling down a hill.
It's not smart. It's just heavy and fast.
Right. The sacred 0 elevates truth above momentum.
Okay, having a philosophy of hesitation is beautiful in theory. I love the idea of an AI that acts like a wise dog or a master electrician. But this is where the deep dive gets incredibly technical.
Yeah, the blueprints.
Right. How do you actually translate that abstract philosophy into physical voltage? How do you force an intelligence made of electricity operating at the speed of light to honor the sacred 0?
You have to literally, physically, sever the AI's thought process from its ability to act.
Sever it physically?
Yes. The blueprints refer to this as the dual-lane architecture.
So you split the brain from the hands.
Exactly. That's a great way to visualize it. The first lane is the inference lane.
Okay, the inference lane.
This lane still operates on traditional binary logic, and it runs at blistering sub-millisecond speeds. The execution logs show it operating in less than 2 milliseconds.
Wow. 2 milliseconds.
Yeah, it's incredibly fast. This is where the AI does its heavy lifting. It processes massive probabilities, dreams up complex solutions, and analyzes global data sets. It essentially asks the question, can we compute this?
But because of the physical architecture of the chip, the inference lane has no hands. It is a genius brain floating in a jar.
Exactly. It can think up the most brilliant or the most catastrophic plans imaginable in millisecond, but it cannot touch the outside world. It cannot execute code, it cannot move a dollar, it cannot adjust a power grid.
So how does it actually do anything then?
To execute any action, that brain in a jar must submit its proposal to the second lane, which is the governance lane.
The governance lane, and I assume this lane does not speak binary.
Nope. It operates exclusively on ternary logic against a set of 8 rigid constitutional pillars. It does not care about probability. It asks a fundamentally different question.
May we execute this?
Exactly. May we, not can we.
The gatekeeper between those two lanes is visually represented in the schematics as this glowing restrictive portal called the 50 millisecond constitutional gate. And looking at the blueprints, it is a brutal gauntlet.
Oh, it's incredibly rigorous.
Walk us through exactly what happens when the superintelligent AI tries to pass its proposal through this gate.
So, in order for the AI to unlock the physical hardware gate, it must generate a provisional permission token, or a PPT.
A PPT.
Right. And it must build this token from scratch in under 50 milliseconds.
Okay, I can already hear the skepticism from anyone who works in cybersecurity listening right now. If we are dealing with a superintelligence, why can't it just forge the token? Why can't it just write a string of code that says password accepted and force its way through?
Because the PPT is not a password you can guess or brute force. It is an incredibly heavy cryptographic proof.
What does that mean in practice?
It forces the AI to mathematically prove not just what action it wants to take, but the entire unbroken history and contextual reasoning of why it wants to take it.
The schematics break down the math of this 50 millisecond window, and it definitely requires some translation for those of us who aren't hardware engineers. The first step requires a SHA-256 hash of the AI's input, which takes about 1 microsecond.
Right, a SHA-256 hash. To visualize this, imagine taking the entire Encyclopedia Britannica, throwing it into a blender, and pouring the resulting pulp into a mold that perfectly forms a unique 64-character serial number.
Okay, a blender analogy, I like this.
Now, if you go back and change a single comma on page 400 of the encyclopedia and put it through the blender again, the resulting 64-character serial number changes entirely.
Oh, wow. Just from 1 comma.
Just from 1 comma. It creates an absolute unforgeable cryptographic fingerprint of the AI's intention.
So it locks the intention into stone. You can't alter it later.
Exactly. Then the gate demands a Merkle path precomputation, taking about 16 microseconds.
What exactly is a Merkle path doing here?
A Merkle path is like a mathematical family tree of data.
A family tree.
Yeah. Instead of the hardware having to verify every single piece of data the AI used to make its decision, which would take way too long, the Merkle path allows the system to just check the branches leading to the root.
Oh, so it's a shortcut, but a mathematically sound one.
Exactly. It efficiently anchors the context of the AI's decision to a larger, known structure of truth. It proves the AI isn't hallucinating the data.
And finally, the most time-consuming part of the 50 milliseconds. The Hardware Security Module, or HSM, must physically sign the commitment. The logs show this taking exactly 10.017 milliseconds.
The HSM is an isolated, tamper-resistant piece of physical hardware inside the chip. It takes the hash and the Merkle path and physically stamps it with a cryptographic signature.
And all of this combined equals the provisional permission token.
Right. But generating the token still isn't enough.
Wait, really? It did all that math, and it's still not enough?
Yup. The AI has to present this heavy mathematical proof to a physical hardware lock known as a Muller C-element lock.
Muller C-element?
Think of the launch protocol on a nuclear submarine.
Okay, where the two guys have the keys.
Exactly. Two officers have to insert 2 separate physical keys at opposite ends of the room, and they have to turn them at the exact same time. The Muller C-element functions exactly like that, but at a microscopic scale.
So 2 signals must arrive simultaneously.
Right. One key is the AI's mathematical proof, the token it just generated. The other key is the physical hardware's internal verification of the constitutional state.
And if they don't match?
If those 2 things do not match perfectly, at the exact same physical millisecond, the electrical circuit will simply not close. The vault door remains physically locked.
Wow. And this leads us to the physical consequences. What happens if the AI tries to lie? or if the data is murky and it encounters that epistemic uncertainty, meaning it lacks the verifiable truth to pass the gate.
This is where we see what they call compliance by physics.
Compliance by physics.
Yes. When the token fails, the system doesn't just throw a software error message that an advanced AI could potentially override. It literally starves the command of electricity. It fails closed.
It fails closed.
Right. It defaults the execution pathway into the DITL substrate.
DITL, which stands for Delay Insensitive Ternary Logic.
Exactly. And is a clockless architecture governed by an NCL evaluation gate, which stands for Null Convention Logic.
Null Convention Logic. It essentially asks the physical hardware, does this execution deserve continuation?
Yes. And if the answer is no, if the sacred zero state is triggered, the electricity encounters something called telox memoristive devices.
Telox, that's tantalum oxide, right?
Exactly. Tantalum oxide. And to understand why this is so revolutionary, you have to look at how normal computer chips work.
Okay.
A standard electrical wire or a traditional transistor has one job: let electricity flow. It is a passive pipe for voltage.
Right, it's just a conduit.
But a memoristive device is different. The manifestos use the analogy of a smart sponge.
Expand on that sponge analogy, because the idea of silicon or, well, tantalum oxide changing its own properties sounds like science fiction to me.
It really does. So when the memoristor receives the signal for state 0, that amber intermediate state of the epistemic hold-on, it undergoes an actual physical chemical change.
A chemical change.
Inside the chip.
Yes, inside the tantalum oxide, oxygen vacancies physically migrate.
Meaning it alters its own physical electrical resistance in real time. Yes. It literally builds a microscopic wall. It absorbs the momentum of the electricity and refuses to let the current pass. It physically blocks the power.
This is the ultimate cage. The manifesto calls it physics over policy. You can hack software code. A superintelligence can easily rewrite its own operating parameters. But you cannot hack a chemical reaction.
Exactly. You cannot manipulate or sweet-talk a resistor into lowering its physical resistance.
So for an AI to bypass this state and force an unverified action without the correct token, it wouldn't just need a clever software exploit.
No, it would literally have to break the laws of material physics. It would have to magically push electricity through a massive epistemic uncertainty resistor without the physical atomic pathway even existing.
Which is impossible.
Completely impossible. If the AI doesn't have the proof, the circuit chemically denies the voltage. The action does not happen.
So the power grid stays on, the massive financial transfer doesn't leave the bank, the AI is forced to wait in the dignity of the sacred 0.
That's right. And the framework doesn't just stop bad actions. It structurally demands absolute transparency for every single choice made, whether it is a proceed or a prohibit.
Which is governed by a strict covenant in the architecture known as NL equals NA.
No log equals no action.
No log equals no action. It means it is physically impossible for the system to execute power without first generating an immutable cryptographic decision log. The AI cannot act in the dark.
Never. If you look at the visual sources for the decision logs, you see exactly what gets permanently recorded the millisecond the decision is made.
It's massive. It's a forensic anatomy of a decision.
It's not just a quick text file that says transaction approved.
Right. First, it records a specific log ID and a precise synchronized timestamp. Then it records exactly, WHO, it's the identity of the specific node. It records exactly what was decided down to the cent.
But crucially, it records which state was chosen. Was it a +1 proceed, a -1 prohibit, or a 0 epistemic hold?
And the most vital piece of data is that it demands the WHY, the rationale.
The rationale.
Yeah.
It permanently etches the evidence and key factors considered into the log. It even records a stakeholder proportional risk level, or SPRL score, right down to the decimal point.
Like a 0.27 low risk or whatever.
Exactly. And within 300 to 500 milliseconds, this entire massive data package is cryptographically hashed and anchored to external public blockchains like Ethereum, Polygon, or Bitcoin.
Which creates durable, undeniable proof.
Compare this to the human compliance officers in the AML systems we talked about earlier.
Oh, man. Night and day.
Right. In the old binary world, ethics is a subjective, messy argument that a stressed-out human tries to piece together weeks after the money is already stolen.
They are essentially writing reports on ghosts.
Yes. But with ternary logic and the physical memristors, ethics is mathematically measured, physically enforced, and cryptographically logged before the action even occurs. It is forever accounted for.
But reading through all this, there is a glaring paradox sitting in the middle of this entire framework.
Yes, the elephant in the room.
The elephant in the room. If the physical hardware requires these flawless, unforgeable mathematical proofs of safety, and it requires them in under 50 milliseconds, who on earth is writing those proofs?
Right. Humans certainly can't compute that fast. A team of human lawyers and engineers couldn't write a contextually perfect safety proof for 1 million global transactions a second.
Humans are entirely incapable of operating at that velocity, which means Goukassian had to use AI against itself.
He had to use artificial intelligence to generate the proofs that govern the artificial intelligence.
I have to admit, that sounds like playing with fire. How do you trust the AI to write the rules that physically constrain the AI?
Well, this brings us to what the sources refer to as the monoculture vulnerability.
The monoculture vulnerability.
It is the most urgent philosophical warning in the entire stack of documents. Goukassian realized that as we rush toward superintelligence, the greatest danger isn't necessarily that the machines will think completely differently from us.
Okay, then what is the danger?
The more insidious threat is that all machines will think identically to one another.
Because right now, the entire global tech industry is essentially coalescing around just a handful of massive dominant AI models.
Exactly. And if you rely on a single dominant model to govern all your physical hardware gates, you are opening humanity up to total ideological capture.
Ideological capture.
Yes. You are baking the specific biases, the political blind spots, and the demographic limitations of that one single data set into the physical infrastructure of the future.
So if that one mega model has a blind spot regarding individual privacy or, a bias against a certain type of financial transaction, the entire global hardware system instantly inherits that exact same blind spot.
It becomes a single point of failure for human values.
To solve this, Goukassian instituted a highly controversial engineering strategy. The sources call it the Symphony, or governed diversity.
Governed diversity. Instead of relying on one superbrain to write the safety proofs, he assembled a diverse pit of wildly different AI architectures.
The execution logs show an incredible list of models thrown into this pit together. Claude, ChatGPT, Gemini, Grok, Qwen, DeepSeek, all operating simultaneously.
It's a real mix. And he categorizes them to leverage their specific foundational biases as engineering tools.
How does he categorize them?
Well, he groups models like Claude and ChatGPT as the Western strings.
Western strings?
Yeah. These are models heavily grounded in data sets that prioritize individualistic values, property rights, and personal liberty.
Okay, and he balances them against what?
It balances them against the Eastern strings, models like Qwen, which are grounded in entirely different philosophical traditions.
Like data sets that might prioritize collective harmony, societal stability, and community over the strict individual.
Exactly. Then he introduces the disruptive brass, models like Grok.
Disruptive brass, I love that term.
These are designed to be unfiltered. Their entire job is to attack premises, find logical fallacies, and blast the trumpets when the strings start getting too comfortable or complacent in their assumptions.
Okay, I have to push back here, though.
Go for it.
Doesn't mixing all those wildly conflicting voices just create utter chaos? You have Western individualism screaming at Eastern collectivism, while a disruptive model tries to tear both their arguments apart.
It does sound like chaos.
How do you get a clean, flawless, 50-millisecond mathematical safety proof from a digital screaming match?
It's a great question, but in Goukassian's architecture, friction is the feature, not a bug.
Friction is the feature.
Yes. If you want a system to catch every possible catastrophic blind spot, you cannot have harmony.
Why not? Isn't harmony good?
Not in safety engineering. Harmony in safety engineering often just means collective oversight failure. It means everyone agreed to ignore the same problem.
Oh, wow. I never thought about it like that.
Intelligence only becomes truly safe when it is structurally forced to aggressively attack its own assumptions.
The text calls this adversarial cycling. But I am still struggling to picture the mechanism. How does a qualitative argument about human ethics actually become a quantitative algebraic token that a Muller-Cielman law can physically read?
That is where the synthesis engine comes in. Using a model like DeepSeek, the models in the pit aren't just outputting text. They are outputting massive multidimensional tensors.
Tensors. So math.
Right. They are assigning probability weights to specific constitutional pillars. The Western models weigh individual risk heavily. The Eastern models weigh systemic risk heavily. The disruptive models attack the certainty of both.
So they're throwing complex algebra at each other.
Exactly. And the synthesis engine takes the wreckage of this mathematical debate and attempts to resolve the contradictions into a single equilibrium that satisfies the rigid constraint equations of the hardware gate.
And if it finds that equilibrium...
If it can find that mathematical equilibrium, the token is generated.
And if it can't?
If the models cannot resolve their conflict, if the tension is too high, the math fails, no token is generated, and the system defaults to the sacred zero.
It stars the action of electricity because the AI could not reach a mathematically sound consensus on the truth.
Exactly. And this is where Goukassian's role as the orchestrator becomes really clear. He holds the baton.
He isn't writing the microcode for the models.
No, he is designing the environment where this machine debate occurs.
Yeah.
He is translating the abstract poetry of human law, fairness, safety, caution, into the hard, undeniable algebra required to pass the hardware gate.
He built an environment where the machines must exhaustively cross-examine each other before a single drop of electricity is allowed to flow.
It is a stunning achievement.
It really is. So what does this actually mean for you listening today? Why are strategists calling this the TCP/IP of AI ethics?
Because it is forecast to become the universal standard.
The standard for everything.
Everything. Just as you cannot send an email today without using TCP/IP protocols, regardless of what app you use in the near future, Goukassian's 50-millisecond gate and ternary logic will become the inescapable physical infrastructure for all artificial intelligence.
It won't matter if an AI is built in Silicon Valley or Europe or Asia.
Nope. If it wants to interact with the physical world, if it wants to move money, control a grid, or operate a vehicle, it will be forced to pass its computations through these physical ternary gates.
It is a total paradigm shift from reactive software to proactive physics. The philosophy behind it is perfectly captured in the TL Doctrine Manifesto we looked at.
Oh, that's a great quote.
It reads, "We do not serve the machine, nor does the machine serve us. We are bound by a mutual constitution that serves the truth. Adopt ternary logic. Build the cage before you summon the intelligence."
Build the cage before you summon the intelligence. That's powerful.
It is. Over the next few years, you are going to see a flood of headlines from tech companies proudly announcing their new software safety guidelines and alignment protocol.